Okay, let me start. So we are in lecture number 12, connecting LANs and backbone networks. So this is the title, the topic of this lecture, connecting LANs, local area networks and backbone networks. Okay, so this is the title of this lecture. Now, so in this lecture, what we are going to study means we are going to cover three major things. So the first one is connecting LANs with connecting devices. So how to connect various local area networks. How we are going to connect the local area networks with connecting devices. So what are all the connecting devices available? How can we connect more than one LAN, local area network? Then we are going to discuss about spanning tree. So there is a very big issue available in the networking. So that is called the spanning tree concept. But we are not going to find the solution for it. What is spanning tree? We are going to discuss in this particular lecture. Then backbone networks. So what is a backbone network? What are all the different types of backbone network available? So these are the major concepts we are going to discuss in this particular lecture. Now, I'm going for the first part. So the first part of this lecture, connecting devices. There are so many devices available. We already studied about this networking devices. Okay, you can see these are all the devices available. So the first one is passive hub. The next one is the active hubs, repeaters, bridges, layer 2 switches, layer 3 switches, routers and gateway. So these are all the different devices available, networking devices. So you must know each device, each and every device is working in which layer of OSI model. Now, if you take passive hub, if you take passive hubs, so passive hubs or active hub, anything, so it is going to be work in the layer 1. That means in the physical layer of your OSI model. So passive hubs, it is in the layer 1. Active hubs also, it is going to be in the layer 1. So it is a layer 1 device. So for multiple choice questions, okay, this is a very important thing. So you must know the name of the device and also the device, okay, in which layer it will be used. Now, if you go for the second device, it is a repeaters. So the repeaters, it is layer 1 device. So it is used in the layer 1 of your OSI model physical layer. Then bridges. So bridges and switches. Okay, we have two things here, two devices, bridges and switches. So both are layer 2. That means data link layer. It is going to work in the data link layer of your OSI model. Then the next one, the next device is the routers and layer 3 switches. Okay, you can see the difference. Layer 3 switches, okay, routers and layer 3 switches. Okay, layer 3 switches. So it is going to be layer 3. So layer 3 means networking layer. Okay, layer 3 is going to be the networking layer. So these are the two devices which are going to work in the layer 3. Then gateways. So gateways we can say in layer 3 and also layer 7 you can say. Okay, because software, okay, for example, there are some gateways which is available in the layer 7 also. Okay, layer 7 also it is available. So we can say it is layer 3 or layer 7, okay, anything. So this is a very important point, okay. So every student must know this. So if you take a device, so you must know in which layer of OSI, okay, the particular device is working. Okay, this is a very important concept. Okay, now, so these are all the devices and each and every device in which layer it is working. Okay, we discussed in this particular slide. Now, I'm going for the first category of connecting devices. Below is the physical layer. Okay, now you can see this is a machine. The first one, this is going to be the first one is a machine. Okay, so this is the first PC. There are 7 layers available and this is the second PC. Okay, all the layers available. Now I'm going to connect these two machines by using a device. So what is the name of the device means I'm going to connect by using a passive hub. So we already discussed, okay, in I think lecture number 6 or 7, networking devices. So in networking devices, we already discussed what are the differences between the passive and active hubs. Okay, I will show it in the next slide. Okay, in the next slide I will repeat it again. So no problem. Now you can see. So this is a PC. This is first PC, and this is going to be the second PC. So the two PCs I'm going to connect by using a hub. Okay, now I'm going to keep a hub device here, a passive hub, and the passive hub will be used to connect these two devices. So what is the concept here? How you can use these devices, okay, to connect different networks or different computers, anything. Now you can see in the next slide. In the next slide, I'm going to use a hub. Okay, so you can see this is the first machine, as usual the same thing. This is PC1 and this is going to be the PC2, the second PC, and you are going to have a device here. So the name of the device I'm going to use hub. So hub is a layer 1 device. It is a layer 1 device. So it is going to work in the physical layer, of our OSI model. Now, what is the difference between physical hub and passive hub and an active hub? Okay, what are the differences? So you can see the differences. The differences are given here. What are the differences between active and passive hub? Okay, so a very simple difference. So what is a active hub means? The active hub will strengthen the signal. If the strength of the signal goes down, it can recreate. Okay, it can recreate the signal or it can regenerate the signal, active hub. Whereas the passive hub, okay, it is not going to do that. It is just simply it is going to split. It is going to split the bandwidth, but whereas an active hub is going to regenerate the signals. Active hubs, they need electricity. You have to provide electricity for the active hub. But for a passive hub, you no need to provide electricity. Without electricity also it can work. It is simply connecting. Okay, it is simply connecting. Active hub is smarter. It is going to be very smart than the passive hub. Okay, so these are all the differences. We already discussed this in some previous lectures. You can refer to the lectures. So you can use anything. You can use an active hub, or you can use a passive hub, or you can use a repeater. So all these devices, it is going to work in the physical layer. It is going to be in the layer 1. So in the layer 1, it will connect two different networks or two different PCs it can connect. Okay, so that is the concept. Now, if you go for the repeater, so what the repeater is going to do? Repeater is almost equal to the active hub. That means a repeater can regenerate the signal. You can extend the distance. Okay, this also we already discussed. So it is going to extend the distance. So the distance means, so only 100 meters you can take a cable, UTP cable, up to 100 meters you can take. But I want to extend my network for 500 meters, means you can use the repeaters. Okay, you can use the device, repeater device. So using the repeater device, you can extend your network. Okay, you can extend your network. You can see. So this is the first segment, that means the first device, the first PC. So I'm going to have a cable, a very long cable I'm going to have. So if the cable is going very long, automatically the strength of the signal may go down. So initially the strength of the signal will be good, then slowly the strength of the signal may go down. So what I have to do? I have to use a device. The name of the device is called the repeater device. So I'm going to use the repeater device. So the repeater device will regenerate the signal. It will increase the strength of the signal, same like before. Then it will be sent. Okay, then it will be sent. So 3 devices. Okay, 3 devices we discussed now. Active hub, passive hub, and repeaters. So all these things are going to work in the layer 1 only, but repeater is smart, it can regenerate the signal. Active hub is very smart, it can regenerate and also it can connect multiple computers. So passive hub, it is not going to regenerate the signal, it is simply connecting the machines. So these are all the devices. Now you can see in the next slide. So in the next slide, what is the function of a repeater? So a repeater is a regenerator. It is going to regenerate the signal. Okay, it is going to regenerate the signal. So you can see the arrow mark. So the signal is coming in this direction. Okay, the signal is coming from here. So automatically during a particular point of time, the strength of the signal, okay, it is going down. Okay, initially, okay, you can start from right to left. So the signal is moving from right to left. Okay, the signal is moving right to left. So in the right side, you can see the strength of the signal. So the strength of the signal is good. Okay, the strength of the signal is good. But whereas, okay, slowly now, okay, while coming to the repeater, so the strength of the signal is going down. Now I'm going to regenerate the signal. So if you regenerate, okay, your signal will be like this. Same thing, left to right or right to left, same thing. So here the signal, okay, it is corrupted signal. Now I'm using a device here, repeater device. Automatically the strength of the signal is going to be the regenerator. So this is the functions of a repeater. A repeater device is doing, okay, these types of job in layer 1, okay, at layer 1. Now you can see the hierarchy of a hub. So what does that means? A hub is a multi-port repeater. A hub is a multi-port repeater. So multi-port means you can connect more than one computers in a hub. But in a repeater, okay, it is going to be only, okay, only one or two connections will be available. Okay, I'll show that to you by using the packet tracer. So you can see in this topology diagram, I created a topology diagram here. Okay, simple topology diagrams. So in order to show, okay, how we can connect the switches, hubs, okay, and the repeaters. Now you can see the first one, the first topology diagram. You can see the first topology. Can you see the screen? I think you are seeing the PowerPoint. Am I right? Yeah, I created some topology diagrams. Okay, here using different devices. Okay, using different devices. So now you can see the first topology diagram. The first one you can see here. The first one I created by using a hub. So hub is a device. Now I'm connecting 1, 2, 3, 4. So 4 devices I connected here. So this is a multi-port. Multi-port. Okay, port number 0, port number 1, port number 2, port number 3, port number 5. Okay, so there are multi-port switch. So I connected many computers like this. For every computer I fix the IP address. Okay, for first computer I am giving 10.0.0.1, 10.0.0.2, 10.0.0.3, 10.0.0.4. Okay, I gave the IP address like this. Now this is a small network I created by using hub. Now I'm going for the next device, repeaters. How to use the repeaters? Okay, you can see I am having a hub. This is hub 1. I connected 3 machines here. Then this is my next hub, okay, which is having 3 devices. The next hub, okay, I'm having 3 devices. Now you just think in our college, okay, this is the LRC building. So we are using, okay, 3 computers with a hub in the LRC. Then this is, okay, library. So in the library we are having 3 machines with a hub. And this is the cafeteria. So we have 3 machines there with a hub. Now all these things I want to connect. Okay, that means I want to extend my local area network. I'm extending the local area network. So how can I extend this local area network? Means I'm going to use the devicer called repeater. Okay, repeater is the device. Now, so the repeater is not multi-port. It is not going to have more ports. It is going to have only 2 ports. Okay, port 0, port 1. Okay, you can see that if I keep the mouse, it is telling what are the ports connected here. So it is going to have only 2 ports, port 1, port 2. So what is the point here? The repeaters will have less number of ports. Less number of ports. That means you cannot connect more computers there. More connections you cannot make. But if you go for the hub, it is multi-port. Okay, you can have many connections here. So here this is a 6 port. Okay, 6 computers you can connect it here maximum. Now I'm extending my network. So this is the first part of my network, the first segment of my network, and this is the second segment, okay, and this is the third segment. So all the three segments I connected by using a repeater device. So whenever the signal goes down, automatically the repeater will regenerate the signal. It will regenerate the signals and it is going to send it to the next hub, okay, the next device. So this is what, okay, we are understanding how to design, okay. Now I'm just going to give the ping command. You can see the first topology and second topology, okay. I'm just going to have a ping command from PC0 to PC3. I'm giving a ping command. Now, so if I give a ping command, so automatically the packet is going to move, okay. I just click the auto capture. So from PC0, okay, to PC3, okay, the packet is moving. So this is a layer 1 device, okay. Hub is a layer 1 device. It is doing broadcasting, okay. You can see the broadcast is going on. So the broadcasting is going on in this case, okay. So it is doing the broadcasting concept. So hub, it is a layer 1 device. It is not a very effective device, okay. Now let me go to the second topology diagram. So in the second topology diagram, I'm going to give the ping command. All of you look at the screen carefully. From PC6, okay, from PC6 to PC12, okay, I'm giving the ping command. So these are all same network, okay. It is a single network, but we are extending the network. That means the distance we are extending by using the repeaters, okay. By using the repeaters, we are just extending the distance of our topology diagram. That means of our network. Now I'm just going to give the auto capture. You can see from PC6 the packet is going to move through the repeaters, okay. So the packet is coming to the hub. Hub is going to do the broadcasting. So it is just broadcasting the packets. Now the packet has reached the repeater. If the signal is not good, it is going to regenerate. Then it is going to the next hub. The next hub is again, it is doing the broadcasting. Then it is going to the next hub. Again, it is going to do the broadcasting. Now my target is PC12. So PC12 is going to give the reply. Again, hub is going to do the broadcast. So every time, okay, the device hub, it is going to do broadcasting. So coming to the repeater, then repeater to hub 2. So hub is now doing the, again it is doing broadcasting. It is not a very smart device, okay. Hub is not a smart device. So every time it will do only the broadcasting. So finally my packet is reaching P6, okay. PC6, the packet is reaching. So this topology diagram we implemented just by using hub, okay. It is an active hub, and in this topology diagram I am using the repeater device. So the repeater device is used. I am extending the repeater. All these things are same network, every PC in the same network, okay. I gave the IP address like 10.0.0.1, 10.0.0.2, 10.0.0.3, 10.0.0.4, 5, 6, 7, 8, 9. So same IP address, I mean the same network, okay. So 10.0.0.1, 10.0.0.2, 3, 4, 5, okay. Like that I assign the IP address. So this diagram, okay, it explains, the topology diagram explains how to connect the hub and how to connect the repeaters, okay. So this is the concept of this particular topology diagrams. Now I'm going for the PowerPoint, okay. So a hub is a multi-port repeater, okay. So it is a multi-port repeater. You can connect more than one device. Hub is used to create the connection between the stations in a physical star topology. That means you can create star topology by using the hub. So this is what we have discussed in the previous slide. That means in the packet tracer, you can create a star topology by using the hub. Then your hub can support 10 base T connections. So 10 base T connection means, okay, this is a popular cabling standard, okay. This is a popular cabling standard for a UTP cable. That means it will support up to 10 Mbps speed. 10 Mbps speed, okay, you can connect, and also your hub you can have up to 100 meters of cable you can have. So that's why we are using repeaters. After 100 meters, automatically the strength of the cable will be, okay, that means the strength of the signal will go down. We have to use a repeater. So what is the point here means your hub is going to support 10 base T. Okay, it is 10 base T. What this 10 base T means? 10 base T means the speed. So what is the speed? Up to 10 Mbps speed and length up to maximum 100 meters of length. The cable length we can use it. Okay, so this is the concept of the hubs, how you can use the hub. Now, so up to this we are completing layer 1. So in layer 1, what are the devices we can use to connect means you can use a active hub, you can use a passive hub, you can use a repeater. Okay, these are the 3 devices, the layer 1 devices, you can use it. Now we are going for layer 2. What are the layer 2 devices? Okay, the layer 2 devices you can use in your network to connect your network. There are 2 devices available in layer 2. So what are the 2 devices means? The first device is a bridge. Okay, it is a bridge. Then the second switch is layer 2 switches. Layer 2 switches. So these are the 2 devices which are working in the layer 2. Okay, in layer 2 of your OSI model. Okay, you can see this is the first PC and this is the second PC. You are going to use a device which is a layer 2 device, data link layer device. So example is bridges. So bridges and layer 2 switches are the examples for that. So this device, it is going to have only 2 layers. Okay, you can connect it and you can use it. Now I'm going for this. Okay, what is the name of the device means? The name of the device is bridge. So bridges, it is going to use in the layer 2. Okay, what the bridges can do? So bridges can filtering capability. Filter means it can stop. A bridge can stop a particular packet. Okay, we should not say packet, we have to say frames because it is layer 2. So a bridge can stop a particular, it can filter. Okay, some packets I want to send, some frames I want to send, some frames I want to stop, you can do it. But the repeaters, it is not like that. Repeaters is a different concept, regenerating. Then, so bridge is going to check the physical address. Physical address means MAC address. It is going to check the MAC address. Please make a note. Okay, in layer 2, in layer 1, everything will be in the form of, that means in the layer 1, everything will be in the form of zeros and ones. That means it is going to be bits. We don't have any address. There is nothing, no address in layer 1. But if you go for layer 2, you are going to use MAC address. Okay, you are going to use. The MAC address will be used. So what is the length of the MAC address means? The length of the MAC address is 48 bits is the length. If you are going for layer 3, in layer 3 we are going to use IPv4 address. Okay, IPv4 address, okay, we can use. So what is the length of the IPv4 address means? 32 bits. Okay, 32 bits is the length of the IPv4 address. Now, in layer 2, we have devices. 2 devices we are going to use. What is the first device means? The first device is the switches. Then the second device is the bridges. Okay, bridges. So switches and bridges. Now both these devices, okay, both these devices, that means the routers and bridges, they are going to see only the MAC address they are going to see. So based on the MAC address only, they are going to forward. They are going to forward the frame or they are going to remove the frame. Okay, they are going to forward the frames or they are going to discard the frames based on the MAC address only. Okay, so this is the point. Now you can see bridges can have the filtering capability. Okay, it can filter some frames, it can forward the frame or it can stop the frame. Then The next one is it checks the physical address. It is going to check the physical address. The physical address is nothing, sorry. So the physical address is nothing, that is going to be the MAC address, okay, of the destination frame. Then it can forward the frame or it can drop the frame, it can do anything. Then it is going to manage a table. Okay, now this is very important point. So what is that means? Every layer, okay, if you take layer 3, in layer 3 you will have a table. What is the name of the table means? That is called the routing table. Routing table. So routing table will be managed in this, okay, layer. If you go for the layer 2, in layer 2, what is the table? Okay, what is the table managed means? So it is going to manage, okay, the table called MAC address table. MAC address table. Okay, so these are the important things everybody should know. Okay, networking student means you must, okay, very clear about this. So layer 3 routing table, layer 2 MAC address table, layer 3 IP address, layer 2 MAC address, layer 3 routers and also switches available here. So what are the devices means? We are having router is a very common device, okay, layer 3 device. Then layer 3 switch, layer 3 switches, okay, we have some types of switches here, so they are called layer 3 switches. So this is a very important concept, that, okay, basic concept that every networking student must aware of this. Okay, so this is what given in this particular slide. Now I am moving to the next slide. In the next slide you can see here I am going to use a bridge here. Okay, see the topology diagram. So there are two networks available. Two computers available here, 1 and 2. This is a LAN, a local area network. I have another local area network, LAN 2. So here there are two machines available. This is the first machine and this is the second machine, two machines available. For every machine there is a MAC address. This is the MAC address of the first machine and this is the MAC address of the second machine. Then if you go for this machine, this is the MAC address. The MAC address is 48 bits length and this is the MAC address of the second machine. Now to connect these two local area network, this is local area network 1 and this is the local area network 2. So I want to connect two local area networks. I use the device bridge. So bridge is a layer 2 device. Okay, now the bridge is going to maintain a table. It is going to maintain a table. This is the table it is going to maintain. What is the table it is going to maintain means? This is called the bridge table. So bridge is going to maintain a table. The name of the table is called the bridge table. What is available inside the bridge table means, you can see inside a bridge table you are having two columns. So what are the two columns means? The first column is the address. It is nothing, it is the MAC address. Okay, it is a MAC address. Then the second column is called the port number, port in which it is connected. Okay, the port number in which it is connected. Okay, now you can see this is port number 1 and this is port number 2. Okay, there are two ports available, okay, connected. So in port number 1, okay, this PC, you no need to memorize, don't memorize, make it in a very simple way, AB. So 41, I take the last two numbers, okay, you can see the last two numbers 41, 41, 42. So 41, 42 connected in the first port, port number 1. 41, 42 connected in the first port. Then this is 12 and 13. So 12 and 13 it is connected in port number 2. So this is called a bridge table. So bridge is a device. It is a layer 2 device. So this device is going to, okay, this device is used to connect two different networks at layer 2. So the bridge is going to manage a table. The name of the table is called, okay, the bridge table. In the bridge table we have two columns. So the first column is the MAC address column and the second column is the port number, okay, the port number column. So this is about how the bridges are used to connect. Then I'm going for the next one. The next one is transparent bridges. Same, the concept of bridges, okay, we are going to continue. Okay, we are going to continue the concept of bridges. Okay, so what is a transparent? Okay, what is a transparent bridge? Okay, the word itself, it is very clear. Transparent means clear, nothing to hide. That is called transparent. Now, the stations are completely unaware of the bridge existence. That means the stations means the computers. We already saw there are 4 computers available in the previous topology diagram. So your stations are completely unaware of the bridge's existence. So your machines, that means the computers in the network, okay, you go to the previous example. So in this machine is completely unaware, it is not going to know there is a bridge available. So this is called transparent. Okay, but the bridge is available, okay, no need to know this or no need to inform this to this. Okay, that means it is going to be very clear. It is a single network. It can manage like a single network without any, okay, disturbance. Now, so in a transparent bridges, stations completely unaware of the bridge's existence. Then stations does not configured or reconfigured with the bridge. Suppose if you remove a bridge, if you add a bridge, if you delete a bridge, nothing. You no need to do anything for your machines. So your machines, that means the stations are completely independent. The bridges are completely independent. So if you configure, you no need to do any changes for your machine. If you remove a bridge from your network, no need to do any changes for your machines. Okay, this is the point. Then the system equipment with the transparent bridges must meet the 3 conditions. What is the 3 conditions? Means the frame must be forwarded from one station to another station. So what that is the use? You can forward, okay, the frames from one to another. The forwarding table is automatically learning. It is going to learn. It is going to create the table. So just now in the previous slide, we discussed the bridge is going to manage a bridge table. So the bridge table will be created automatically. It will be created automatically without disturbing the machines, without disturbing the stations. Okay, your bridge will automatically create the table. How it is going to create, we are going to see in the next slides. Okay, in the next slide, we are going to see how it is going to create. Then, the loops in the system must be prevented. What is the loop? This also we are going to discuss. Sometimes there will be a loop will be created. What is loop? You may not understand at this stage, no need to worry, okay, it is coming. So these loops can be prevented by using the bridges. The bridges can prevent the loops, okay, it can prevent the loops. Then the bridges can forward the frames. It is going to do the forwarding from the one network to the another network. It is going to do the forwarding concept. So forwarding means it is going to send. Okay, it is going to send the data from one network to another network. There. So your bridges, you can say bridges or transparent bridges. Okay, it is same. So what the bridges is doing, it is going to learn. It is going to create its own table. The forwarding table, it will create own table. It will create. Okay, it will create its own, or we can create. The administrator also can create. That is called the static forwarding table, dynamic forwarding table. So static forwarding table means the administrator will create the table. Dynamic forwarding table means automatically, okay, the bridges will create its own table. Okay, it will create. So how it is going to create? You can see in the next slide. You can see a learning bridge and the process of learning. Okay, we are going to explain now. Okay, all of you look at this diagram carefully. See, this is PCA, this is PCB, okay, PCC, PCD, E, F. There are 6 machines available now. So I'm going to say this is LAN 1, local area network 1, and this is local area network 2, and this is local area network 3. There are 3 local area networks connected in this bridge. So with this bridge, we are connecting 3 local area networks. Now, in the beginning, the table is empty. That means the bridging table is empty. There is nothing available in this table. It is going to be completely empty. So the first column, what is the first column means? The first column is the MAC address. The first column is a MAC address. The second column is a port. Port number is the second column. Now in the switch there is nothing available. Okay, everything is empty. Okay. Now I am going to send a data. Okay, you can see. After A sends the frame to D, that means from A I want to send a frame to D. Okay, I am going to send from A to D. I am going to send a frame. Now, so the frame is coming from this machine. Okay, you can see the lines that I am putting. So this is from A. The frame is coming to the bridge. Okay, it is coming to the bridge. Now, bridge is automatically it is going to learn. So what it is learning? That means A is connected in port number 1. It is going to learn. So A is connected is 1. That means the system A is connected in port number 1. Automatically it makes a entry in the table. This is called learning process. The process of learning. Then it is going to send it. Okay, so I want to send it to D. So where is D available means? So the D is available here. Okay, the D is available in this frame. Now I am going to send it. Okay, I am going to send it to D. Okay, it is going to reach. Then this is one step. They are going for the another. After E sends a frame to A. Okay, what is that means? They are taking E. Okay, I'm not going to take E. Let me take A. I'm going for the reverse. Now from D to A, I want to send the data. I'm going to give the reply. From D to A, I'm going to give the reply. Now from the D, the packet is going to start. Okay, the packet is, that means not packet, frame. So the frame is going to start because we are dealing with the layer 2. Now the frame is going to come. Okay, it is going to reach the bridge. Now the bridge is understanding D is the name of the system. Okay, or MAC address. For D, it is connected in port number 2. It is port number. It is available in port number 2. So it is going to update the table. So then, then the data will be given to A. So this is how your bridge is going to learn. So finally, if you see in your bridging table, so everything will be available. All the entries will be available. Entries means A, B, C, D, E, F. Okay, all the machines. Okay, which is connected in which port number. Everything will be connected. So this concept is called the process of learning. Not only bridge. Okay, try to understand. Not only bridge. Your switch is also going to do the same thing. Switch is also going to learn like this. Routers also going to learn like this, but in routers we will use routing protocol. Okay, routing protocols we will use. So this is how we can we can understand the learning process. Okay, the learning process of a what is that? The device. The device is the bridge. So how the learning, how the bridges learns. Okay, this is the concept. Now I'm going for the next one. Loop problems in learning bridge. Okay, what is this loop problem? So the loop problem, or we can say it is a spanning tree problem. Okay, spanning tree problem. I will explain this concept by using a small example. What is the spanning problem? Okay, now you can see I am having 3 devices connected like this. This is my first device, and this is the second device, and this is the third device. Okay, this is the 3 devices I am having. Now I am going to connect the 3 devices. Are you with me? Any one of you please confirm?
Yes, Mr.
Okay. Now I connect the 3 devices like this. Okay, 3 devices connected like this. Okay, I'm going to talk about the loops problem. Okay, in bridges or in switches, anywhere. Now this is the device A. Okay, and this is going to be device B, and this is going to be the device C. There are 3 devices available here. Now A is going to send a packet to A and C. Okay, they are forwarding. Okay, they are forwarding the packets. So A is forwarding the packet to B and A is forwarding the packet to C. Okay, this is the packet of A. Okay, for example, you take this is a hello packet. So A is telling the hello to B and A is telling hello to C. Okay, this is the packet of hello. Now, what is happening means the next step, C is going to forward. C is forward. Okay, C is going to forward the packet. Okay, it is doing the broadcast. C is going to forward the packet of A to B and at the same time, okay, so B is going to forward the packet of A to C. This is broadcasting. Okay, now what is happening means the next stage, this is the second step. In the third step, what is again happening means B is going to forward the packet of A again here and then C is going to forward the packet. Okay, C is going to forward the packet of A. So that means whatever the packet, okay, hello packet sent by A, so A is going to get it back. A is going to get it back. That means this is called the loop. This is called the loop. So A packet going to C, then it is going to B, then it is going to reach A again in this direction. In other direction, A is sending his own packet to B, B is forwarding to C, again C is going to forward to A. So what is happening means the same packet whatever A sent, it is going to get it back in a different way. This concept is called loops. This is called loops. So what is the problem of these loops means? The problem of the loops, what is the problem of the loop means? Because of the loop in your table, that means in your okay MAC address table or in the not routing table, in the switching table, okay, or in the bridging table, what will happen means about A so many times you have to enter. That means repeated number of entries. A about A is connected here, A is connected here. So repeated number of entries will be available. Okay, you take this machine. You take this machine. What is this machine? For this C, I make a table now. So what is written? A is coming from here. So I make A. A is connected in, okay, you take this port number 1. A is connected in 1. Okay, I am writing like this. Then this machine is giving the information of A. Now I am going to write again A. A is connected in this button. Okay, that means in this particular, sorry, in this port here. So in this port I am going to make it as 2. So what is happening? 2 times I am entering the data of A. Same thing, you come to this machine, you will understand better. I use a different color now. See, this is port number 1, this is port number 2. Now this person is going to make a table, is going to update, is going to okay make his own table, okay, learning process. So in the learning process, what I understand, A is coming here means, so A is connected in port number 1, I update. Then this person also sending the the data of A, that means the frame received from here is forwarding. Again I am going to write it A. So A is connected in 2, I am writing. So this is going to be the problem.
Mister?
Yes.
You mean for A it is like message?
Yeah, actually not message. I am available in this place. It is a hello packet. Hello packet. Okay, it is not the message. It is telling A is A. Okay, see, A is sending. You will understand now. Wait, I'll give you the example. Okay, you can see in the next slide. They are giving an example. This example is very big. That's why I made a very simple example for you. Now you can see here. So what is the concept means? The entry, multiple entries will be entered. Okay, because of this looping problem, multiple entries will be available in the tables. Okay, now can you see the screen carefully? See. So station A sends a frame to station D. Okay, what is station A? This is station A. Okay, you just see the color. Station A sends a frame to station D. Okay, station D. Okay, now the frame is coming from A. Okay, follow the steps. Okay, follow the line. Okay, see, from A from A, okay, so the packet is moving, the packet is going to this bridge, okay, it is going to this bridge, then from this bridge the packet is going to, okay, reach D, okay, it is going to reach D. This is path number 1. There is one more path. What is one more path? You can go in this, okay, then your packet can come in this. This is the one more path. One more path. So what, okay, D is understanding same the data A, not data, the packet of A. You take it like this. The packet of A is coming in 2 places. So in this table, what is the table? It is going to create a table. So in this table, it will make multiple entry. Multiple entry means, that means A is connected, first A is connected in 2, okay, you see this 2 in bridge number 1. So I take B1, bridge 1, I am writing here as bridge 1, 2. Then again I am receiving the same packet of A, but this is available in bridge 2 of 2. So I am going for bridge 2 of 2. So there are 2 entries available. There are 2 entries available. Is this correct? Means this is not correct. The same thing I explained here. I explained this here in a very simple way. Okay. So A is also giving his own packet and A is giving the packet to C. C is forwarding to me. C is forwarding to me. So what is happening? I am going to make 2 entries in my table. So A is connected in port number 1. So A is connected in port number 2. So 2 entries I make. So the same thing for C also it will make 2 entry, okay, because C will directly give the packet and A will forward the packet. For C also there will be 2 entry available. So in every router, sorry, every device, okay, every bridge, if you go and see, there will be 2 entries available for others. Okay, in A, B and C will be entered 2 times. In C, A and B will be entered 2 times. In B, A and C will be entered 2 times. So this is called, okay, the spanning tree problem. This is called spanning tree problem. Okay, now you can see what is a spanning tree problem means. In a spanning tree problem, okay, there will be a loop will be created. Okay, the loop will be created. Then everybody will have more than one entry. Okay, so this is going to be a very big issue. Now see, now I want to send a packet from here to A. I want to send a packet. Now the packet will go in 2 directions. From B I want to send a packet. Okay, to A means it will go and check the table. In the table there are 2 different paths. There are 2 different paths available. So the packet will go in this direction and also the packet will go in this direction. It is waste of time. There is no use of managing the table. So spanning tree issues. What is the spanning tree issue means? A loop will be created. So because of that loop, whatever you are sending, that means the echo concept, whatever you are sending, you are going to get the same concept, same packet, you are going to get it again. Okay, you are going to get it. So C is sending the packet of A and C is receiving the packet of A. B is sending the packet A here and B is receiving the packet A here. So this problem is available. Okay, this is going to be the spanning tree problem. So this spanning tree problem we can avoid. We can avoid by using a protocol. The name of the protocol is called a spanning tree protocol. So this you will study in the next course. Data, what is that? Introduction to routing and switching. There is a course available. So in that course, how to reduce this spanning tree problem, how you can avoid the spanning tree problem. Okay, you will study that. Okay, but try to understand what is spanning tree. Okay, this is the spanning tree concept. Okay, now the next one, steps of connected LANs and its graph representation. So what is the graph means? For every link you have to give some weightage. Okay, that is called the cost. Okay, cost. Okay, now you see this is a local area network. So B1, bridge 1, bridge 2, bridge 3, bridge 4, bridge 5. Okay, there are so many bridges available. So for every link there is a cost. What is that cost means? The cost is nothing. It could be anything. It could be the bandwidth or it could be a hop count. All these things clearly you will study in the next course. Okay, here we are simply giving some introduction. Okay, you see they are giving a cost 0, 1, 0, 1, okay, different cost they are giving. Okay, maybe 2, 3, 4, 5, this is called the cost. Okay, if you want to understand very clearly, you see this is one computer, this is the another computer, and this is the another computer. So I am going to make a graph. So this is the graph I am going to make. Now, so for this graph, for every graph we can give a weightage, a cost. So I am going to say the cost for this link is 5. Okay, the cost for this link is 4. The cost for this link is 3. Suppose, okay, so this is going to be the cost. So what is the cost means? It could be anything. It could be the bandwidth, okay, or it could be the bandwidth. First one is the bandwidth. It could be the delay, okay, transmission time. There are different terms available. Okay, all these things you will study in the routing protocols. So in the next course you will study. So what is the point here? For every every link there is a weightage. You can give some weightage and you can use it. Okay, so this is the concept of this is. Now moving to the next one, routing bridges. So in the bridges, if you use bridges, we already discussed, okay, loops will be created. You can, another way to prevent the loops. So how you can prevent the loops? The loops will be created. Okay, what is a loop? I explained to you. So how you can prevent the loops means you can prevent the loops by manual configuration. Okay, you have to use a manual configuration. The manual configurations we can do, and also you can use a concept called token ring, okay, LANs. But the token rings we are not at all using nowadays. So it is completely outdated. Actually, if you ask me, to be very frank, even bridges we are not using. Only two devices we are using nowadays, only the layer 2 switch and layer 3 router. Okay, so these are the two devices we are now using in the daily, that means in the day-to-day networks. Okay, now, so bridges connecting different LANs, there are different LANs available. So you can see the bridges. Okay, the bridges will connect different local area networks. So when you are connecting different local area networks, what are the different issues? So these are all the different issues, okay, you may get. Okay, what are the different issues means? The first issue going to be the format, frame format. That means the format of the frames. Okay, format. Every local area network, okay, for example, you say this is my local area network, first local area network. I am connecting with the bridge, and this is my local area network 2, second local area network. So, okay, this is the bridge device. Okay, this is a bridge device. Now, every local area network, every LAN will have a different frame format. So, in LAN 1, I am going to have a different format of frame. Okay, different format means slightly it may vary, not exactly entirely different, slightly it may vary. So, in LAN 2, I am going to have a different different format of my frame. So, now if I send it from here to here, automatically there is some issues available. So, the format of the frame, that is going to be the first issue. Then maximum data size, the size of the frame, this is the another problem. Some networks, okay, you can have larger frame. Here I am going to have the frame size larger, and this local area network, it is going to support only small. So in that case the problem will happen. So maximum size of the frame. Then the next one is the data rate, the speed of the network. That means, so this local area network will be very fast and this local area network will be very slow. So in that case, if you use a bridge, okay, the problem may happen. Then bit order, security, multimedia support. So these are all so many different, okay, parameters. So some security, this local area network is very secured and here it is not secured. Then the order of sending. The order of sending means first bit, second bit, third bit. So you have to send it in the order. For some local area network, you no need to send it in order. You can send it in any order. So these are all the issues. Different issues, okay, may arise. Okay, may arise if you connect two different local area networks by using bridges. All these things are waste. You no need to study because we are not at all going to use bridge. We are going to use only routers. If you use routers to connect, all the problems will be solved. Okay, these are all old data. Nowadays, okay, you no need to, the bridges people are not at all using in the connecting different LANs. For connecting different local area networks, nowadays bridges is not completely used. Okay, it is not at all used. There. Next one, so up to this we are completing the bridging concept. Now we are going for the switching concept, switches. So switches, it is a very important device. It is a layer 2 device. It is an intelligent device. So now we use only these devices in our networks. Switch, layer 2 switch. So this device is going to handle only the MAC address. That means the frames. Okay, it is going to work in the layer 2. Okay, it is an intelligent device. There are different methods of switches available. I think we already discussed this. Cut through switches, store and forward switches. There are two different types we discussed. So store and forward means it will receive the entire frame, it will check for the errors, then it will forward. Okay, cut through switch, store and forward, store and forward. Cut through means it is not going to check any errors, simply it will forward. We already discussed about this in the previous lectures. So there is nothing to discuss more here. So layer 2 switches, this is very common switches we use nowadays. It's a very intelligent device. It is faster. It will avoid the collisions. It will filter the packets. Okay, it will have the buffer. Okay, that means storage. It will almost, it is going to be like a computer. Okay, it will be like a computer. So this is the layer 2 switch only we are using nowadays in our networks. Okay, bridges and all, it is completely outdated. Okay, we are not at all using. See, routers we are using, switches we are using, bridges, okay, repeaters, hubs, all these things are outdated. It is completely gone. Okay, it's completely gone. Okay. Now I'm going for the next device. The next device is the routers. Routers, it is the main, the very important device, okay, that we use in our networks to connect different networks. So it is a layer 3 device. It is a layer 3 device. And it is going to work in the layer 3 network layer, that means IP address, logical address. So this device is used to connect different local area networks, and you can make the wide area network, that means the internet. The complete internet is working based on the router only. Okay, so many local area networks connected through the routers and creating the internet. So the entire internet is depend on the routers only. So this is going to manage the routing table. So what type of table it is going to manage means routing table. In layer 3, routing table. So the routing table you can create in two different ways. Two different ways you can create. One is called the dynamic method. We are going to see in the next course. And also in the static method. So static method we are going to study in the next lecture. So routing tables you can create in a dynamic method, or you can use a static method also you can do. So static method means the administrator will create. So here how to create a route, how to create a dynamic, static routing, we are going to discuss it in the coming lectures. In the lecture number maybe 12 or 13 we are going to discuss about that. Then this is going to build the routing table by using some routing protocols. These are all big. This is one course. Routing protocol is a course. It's a complete course. What is a routing protocol? Complete course we are going to discuss. Then no collision. So it may avoid the collisions. So the routers is going to avoid the collisions in your networks. Now layer 3 switches. This is a latest topic. This is a new one. That means, okay, make a note. Switches can work in two layers. So layer 2 switches available, layer 3 switches also available. So about layer 3 switches you will study only in the final semester. The final semester, that means in the 4th year, there is a course called internetworking. In the internetworking course only you will study about this layer 3 switch. So it is a router but faster and more sophisticated. So a layer 3 switch, it is almost equal to a router. It is having some different functions. I'm not going to tell everything now. Just keep it in your mind. Layer 3 switches available. That's it. Okay, so layer 3 switches available. It will work in the layer 3. The switch will work in layer 3. So it is going to be a very fast and more sophisticated, very fast device. So here you are going to have some tables, some forwarding tables will be available. So what is the name of the table? Okay, I'm not going to tell now. Okay, you will see it later. Okay, not now. So there is a device available. The name of the device is layer 3 switch. Okay, this is now. So up to this we are completing. Okay, all the different types of connecting. Okay, connecting devices we have completed up to this. Okay, that is the router layer 3. So router is working in the layer 3. Okay, it is working in the layer 3. Okay, layer 3 switch, it is also working in the layer 3. So up to this we are completing the different types of connecting devices. In layer 1, hubs and repeaters. In layer 2, switches and bridges. In layer 3 we have routers and layer 3 switches. So these are the concept available in this particular. Up to this, these are the things. Now if you go to the next one, broadcast domain and collision domains. So this also I'm not going to teach now because it needs some exercise. Okay, in the next class I will do this. I will give you some examples. Okay, in exam you will be given a topology diagram. A topology diagram they will give, and they may ask you to find how many broadcast domains and how many collision domains available. Okay, they will ask you. So this is a big thing. So I'm not going to touch this part. Okay, finding the broadcast domain and finding the collision domain, we will see it in the next class. Okay, in the next class I will explain this. I'm just writing what are the pending things. In the previous lecture we have not discussed about the CSMA. That also I will give it to you. And this lecture, finding the broadcast and collision domain, broadcast domain and collision domain, this also I'm not giving it to you. So this all we will cover it in the next class. Okay, because this, if I take this, the entire class, I have to spend for this. I will do it in the next class. Now the next one is the fifth category, the last category. So what is the last category of connecting devices means? It is called the gateway. So gateways, I already explained, I already told, it is going to work in the layer 7. That means application layer. Okay, you can see. So this is the first machine and this is the second machine. Okay, so I'm going to connect this in layer layer 7. So a gateway is going to work in the layer 7. Okay, gateway is nothing, maybe some servers. Okay, it will be some servers. Okay, you can use it for connecting your networks. Now, so normally operates in the 5 layers of the internet or the 7 layers of OSI model. So it is going to be the 7th layer, the top layer. So here everything will be as a application. For example, you will use some proxy servers. Okay, proxy servers will be available. So using that servers you can connect. Okay, if you want to make it in a very simple way, you see this is one network and this is the another network. So these two networks I want to connect. Okay, I want to connect. So what I can use means I can use a gateway software. Okay, a gateway software I can use it. So the gateway software is going to work in the layer 7 of the OSI model. So these are all different ways, different methods available how you can connect your networks, different networks how we can connect. Okay, so this is the concept. So here also you can allow a packet. Okay, you can stop the packet. Okay, suppose I don't want to allow a particular website, I can do it. Facebook, I don't want to work in the college, we can do it in the proxy. There is a proxy server. Okay, in our college the proxy server is used. So in the proxy server, using the proxy server, they can block anything. Okay, they can block a particular website, they can block a particular port number, they can block a particular software. Okay, all these things they can do it in the application layer. Okay, so this is the concept. And firewall, you might have heard about the firewalls. Okay, firewall concept. The firewall concept also, okay, you can have in the gateway machines. Okay, firewall also can run here, application firewall also you can have in this particular place. So this is how you can connect different methods of connecting the devices. Okay, now, so up to this we are completing what are the different ways you can connect your networks. Okay, you can connect your networks, we discussed up to this. Now, I am going for the last concept in this lecture. So the last concept is the backbone network. So what do you mean by a backbone network means? A backbone network allows several local area networks to be connected. So if you connect many local area networks, okay, if you connect many local area networks, so that the backbone network will be used for it. Okay, so a backbone network, no station is directly connected to the backbone. So no computers, no individual computers will be connected to the backbone network, but whereas it will be local area networks. Okay, for example, this is a local area network. I have 100 computers. This is another local area network with 100 computers. I have another 100 computers. This is another local area network. Now, I am going to use a backbone network. Using the backbone network, I can connect these local area networks. So this is called the backbone networks. So a backbone network are used to connect the networks, not the PCs, not the individual stations. So the stations are part of the local area network. So the stations available here, there are so many computers available here. Okay, you can have any number of computers. So inside this you can have lot of computers. So inside this you can have lot of computers. Okay, lot of computers available here. So all these things, this is local area network 1, local area network 2, local area network 3. So all the local area networks I am going to connect it, okay, as a backbone, using backbone. So now if you take the backbone, there are 3 different types available: bus backbone, star backbone, connecting a remote LANs. These are the 3 different types of backbone, okay, structure, the backbone architecture available. Now I am going for the bus. So bus backbone. So what is this bus backbone? Okay, you can see the diagram, you will understand it very clearly. Now a bus backbone means, you can see this is going to be a backbone cable. Okay, a backbone cable. Now I have 4 local area networks: local area network 1, local area network 2, 3, 4. There are 4 local area networks available. Now all the backbone, this is like a bus, the state. Now I use a bridge device. So bridge is layer 2 device. Okay, it is a layer 2 device. So using this device I am going to connect it. Okay, I am going to connect it now. So this is bridge, bridge, bridge. So I am connecting the first local area network, I am connecting the second local area network, third local area network, fourth local area network. So this is going to be the bus backbone. So it will be in the bus structure, a straight cable. You can connect any number of local area networks, you can connect there. If you go for the star, what is a star means? You are going to use a switch. You are going to use a switch. So now you can see. So this is going to be a switch. Okay, a switch is having multiple ports, port number 1, port number 2, port number 3, 4, 5, 6 ports available. So in every port I am going to connect a LAN. Okay, this is a local area network, LAN 1, LAN 2, LAN 3, LAN 4, LAN 5. So there are 5 different LANs or 6 different LANs available. So all the 6 LANs I connected, okay, with this particular switch. Now this I am going to say a star backbone. So star backbone means it is like this. This is a switch. We are connecting like this. Actually it is not network, it is not LAN, it will be VLAN. You will understand this later. So these are all called virtual LANs. So this is a switch. So in switch you can make a star like this. So this is going to be the star backbone concept. Then the next one is connecting remote LANs with bridges. Okay, so what is the remote LANs means? It is also the same concept, you can see here. Now I am having, this is the first, okay, 3 local area network 3. This is local area network 1, and this is local area network 2. So there are 3 local area networks available. Now these 2 things, okay, these 2 networks are called point to point. Okay, this is a point to point and this is a point to point. Now where is this word? okay, the remote comes means you can see there is a distance. So this is available in a different place. For example, this is take our college. These two available in our college, and this portion is available in a different place. Okay, for example, this is Sogar. Okay, this is the Sogar college. Now I'm going to connect this by using, okay, a telephone line. I can use the telephone lines. Okay, that means Umantel connection, or I can use the ADSL connection. Okay, the remote lines, that means telephone connections. Okay, I can use it and I can connect this particular point. So this is called the remote. Okay, through internet. Okay, the concept is very simple. This is through, okay, the internet. Okay, through internet I'm going to connect it. So what is the protocol used here? We are going to use the protocol called PPP protocol. So what is PPP means? Point to point. Okay, point to point protocol. Okay, point to point protocol will be used for connecting this. So these two things, it is available in one place, in one geographical location, and this is going to be a remote one, okay, which is available in a different place. So we are going to use the public network. So public network means some ISP, internet service providers. So you are going to use the internet providers help, that means the internet connection. You are having the internet connection. So using the internet connection, you are going to connect it. So this is about the connecting concept. Okay. So with this, I am completing this lecture. So only one thing is pending, that is broadcasting and broadcast domain and collision domain concept. So that we are going to see in the next class.